Hey guys, continuing to take your questions on 10.4, the section on using square roots to solve quadratics. Right now we're going to take a look at 44. So 44 looks like this. Now they had used the variable t. I don't like that just because my t's look like plus signs, so I just switched it to x. So we've got the quantity x minus 5 divided by 3 squared equals 49. Now again, I'm going to draw my honkin' tonkin' line here. And again, so we want to look at undoing this thing, which again includes doing order of operations backwards. And so it helps me to think about if we knew what x was, because that's what we're trying to do, is figure out what x is that makes this thing true. If we knew what x was, what order would we do things in? All right. So if I knew what x was, the first thing I would do would be subtract 5. All right. Then I would divide by 3. And then finally, I would square whatever answer I got. All right. So that's what order of operations would tell us to do. So when we're solving this thing, we want to do all of that backwards. All right. So whereas the square was the last thing we did in order of operations, that's going to be the first thing we undo. All right. So to undo a square, I'm going to square root both sides. All right. And so the square and the square root are inverses of each other. So what I get is x minus 5 divided by 3, all right, equals, now remember when we do the square root, when we're solving these, we actually get two different answers there, 7 and negative 7, all right? So in other words, this thing squared equals 49. This thing could be two different numbers. There are two different numbers that when you square them, you get 49, positive 7 and negative 7. All right. Now, at this point, what I'm going to do is I'm going to kind of solve this, two different ways here. All right. So I've got x minus 5 divided by 3 could be 7, or x minus 5 divided by 3 could be negative 7. I think it's going to be helpful here just to split this plus or minus and go ahead and split it up into two different equations. All right. But now I've got, and these are really just two-step equations here. All right. So again, let's do this one. We're still undoing order of operations. All right. So if I knew what x was, the first thing I would do would be subtract 5. And then I would divide by 3 because that division symbol is like a grouping symbol, and we want to do the stuff up top. And then finally divide. So I'm going to undo it the opposite by multiplying by 3. So divided by 3 and times 3 cancels each other out. I really don't like that word, but we'll go with it. So I get x minus 5 equals 21. And then when I add 5 to both sides, this side I get x could be 26. All right. Now over here, I'm going to do the same thing, except I'm talking about a negative 7 now. So I'm going to multiply by 3 on both sides again, and I get x minus 5 equals negative 21 now. And now when I add 5 to both sides, I get x equals negative 16. All right. So again, two different answers here, two different solutions, but both of those should make the original equation true. And let's just check those real quick. So I'm going to go back to the original. So let me get rid of these square roots. So if I put in 26, again, doing order of operations now, 26 minus 5 is 21. 21 divided by 3 is 7, and 7 squared is 49. 26 makes that equation true. What about negative 16? Negative 16 minus 5 gives me negative 21. Negative 21 divided by 3 is negative 7, and then negative 7 squared is 49. So again, pretty confident that we have found, and again, we're expecting two solutions here because it is a quadratic. I'm pretty sure we have found the two solutions to that equation. All right, so recognizing order of operations, how to undo order of operations, especially when they're involving square roots. And then don't forget, anytime you take the square root of both sides of an equation, you really get those two different answers, the positive root of that and then the negative root of 49. All right, hope that helps. Let me know if you have any other questions. Take care, guys.